Hello, students. Welcome back. Last time we were talking about Earth's structure. We said the Earth is, in fact, stratified. Based on its early formation, it cooled from the outside in, right? In other words, it sort of scabbed over. The heavy material sunk to the core, the denser iron created the core. We then have a larger, more voluminous layer of the Earth known as the mantle, and then a very, very thin outer shell that we call the crust. It is going to be the crust that we're going to focus on, considering that's where we live, that's what we know. And as a result, we're going to look at the composition of that. When we talk about the crust, the basic building blocks of it are what we call minerals. And to be a mineral, minerals have to occur naturally in Earth's crust. So they're not man-made. They are solid. They are inorganic. Inorganic means they're not coming from things that were once living. They have a definite chemical composition, and the atoms of that composition are arranged in an orderly pattern. And it's that structure that determines the characteristics of the mineral. So let's talk about some of those characteristics and how we can identify minerals based on those characteristics. Color is obviously something that would jump out at you as you pick up a mineral. However, in terms of identifying a mineral, color is probably the least useful characteristic. The reason is some minerals have very different colors. For example, the top left, we have quartz. The bottom left, we have quartz. Both are quartz, but we have a rose quartz and a clear quartz. There can be some impurities like aluminum which cause it to appear this sort of pinkish rosy color. So color alone is not going to be too useful. Furthermore, some minerals share the same color. Right? For example, here we have quartz once again, and then we also have calcite. Both are transparent, but they are different minerals. There's other clues going on in here. For example, the calcite on the right, if you look, serves as a polarizing prism. In other words, when light passes through it, it refracts the light, causing us to see too. And as you can look at the backdrop, you can see how we see a double refraction of these lines as we peer through calcite. So instead of color, we look for other characteristics. One characteristic is luster. How does it reflect light? And there's two different types of luster. The first one is known as metallic, and that's the top right picture, galena. It looks like a metal. And what do I mean by that? If you were to look at any pots or pans that you have at home, it's going to look silver, chrome, gold, right? Copper. These are metallic minerals. Non-metallic don't have that same luster, right? They appear pearly, waxy, glassy, or dull. Another really important characteristic of minerals is its streak, and the streak is the color of the mineral in its powdered form. This is the mineral hematite. Notice how it appears silvery. Well, there's some minerals of hematite that appear red, brown, orange, many different colors, but guess what? The streak, the powdered color of it, is always this reddish, rusty color. That never changes. And the way we test it is by grinding the actual mineral across a streak plate. Notice it's a dark mineral, so it makes sense that we're going to use a light or a white streak plate for contrast. If it was a light mineral, we'd use a dark one for contrast. We always keep the streak plate on the table so that we don't cut ourselves if it breaks in our hand. Here's hematite again, two different colors, which are very different from this hematite. Notice this one appears red with little tiny bumps. This one's almost black to gray, but guess what? The streak is the same. So streak is very useful as an indicator in terms of characteristics of the mineral. It also turns out that minerals break differently. Some break along flat surfaces or planes. We call these minerals, they say they have cleavage, or they break along a flat surface. And here's biotite mica. You can see these flat layers of mineral that peel along a flat surface. If it doesn't have cleavage, if it doesn't break along a flat plane or surface, it's said to have fracture. Here's sulfur. As you can see, it breaks with no rhyme or reason. Finally, we can actually test its hardness. Hardness is really a resistance to scratching. In this particular case, we have a mineral and a glass plate. We're going to actually conduct a lot of these tests in class. We always keep the glass plate on the table, and we grind the actual mineral into the glass plate. If it leaves a scratch, if you can feel it scour and it leaves a scratch in the glass, it means the mineral is harder than the glass. As you can see, glass has a hardness of 5.5. The Mohs hardness scale ranges from 1 to 10, 10 being the hardest. Diamond is the hardest mineral on planet Earth. In fact, we need diamond-tipped saws just to cut through diamond. So the hardness value means it's harder than or than the mineral below it, and it can scratch itself as well. Talc, which is like talcum powder or baby powder, is the softest. Higher values can scratch talc. So here we have two minerals that look very similar, in fact. They have slightly different cleavage patterns, but they break along flat surfaces. They're both transparent, same colors. So how do we know and how do we set them apart? This one sort of has a parallelogram type cleavage. This one breaks along perpendicular or right angles. Well, I'll give you a little clue here. The one on the right tastes a little salty. The one on the left does not taste salty. We're not going to taste these minerals for a good reason. We often do chemical tests with them. We actually place a weak acid on these minerals to see if it bubbles, because we're looking for a reaction. It turns out that calcium carbonate bubbles when you put a weak acid like hydrochloric acid on it. Calcium carbonate are the elements found in the mineral calcite. Now, calcite looks just like halite, but it's made of something entirely different. It's a base, and if you put an acid on a base, there's a reaction where the calcium carbonate fizzes, releasing carbon dioxide, so there's a chemical reaction. Now, halite, which tastes salty, will not bubble with acid. So that is a really good test to determine the difference between those minerals. That's it for now, guys. We'll see you later.